So evolution is descent with modification, and I'm sure you've heard that phrase, survival of the fittest. Well, if you're very fit and you survive, you will not pass along your genes unless you reproduce, and evolution involves reproduction of the fittest. So really we shouldn't be saying survival of the fittest, it's really more like reproduction of the fittest. So let's say that way back when in Africa, tigers did not used to have stripes. And when that tiger reproduces in the next generation, those baby tigers would also not inherit any kind of stripes. And let's say that on average, each adult tiger leaves 2 offspring, and then those can go on into the next generation, and so forth and so on. But let's say that somewhere along the way, maybe during DNA replication, there are some random mistakes that did not get corrected or repaired, and so you may end up with a random set of mutations, one of which perhaps might have caused this baby tiger to now have stripes. And let's just say that that baby tiger now has a better time of finding prey, because it can sneak up to prey in the grass and not be seen, and probably eats better. At the same time, it's better able to avoid hunters with guns, predators, and maybe even the striped tiger might have more reproductive success, because maybe the other tigers think stripes are the cat's meow and this is very sexy, and they will probably mate preferentially with this striped tiger as opposed to its non-striped contemporaries. So what that means is that over time, when you take a snapshot of the population at each generation, then you may see the incidence of stripes among tigers increase over time because of all of those reasons. And of course, when the striped tiger reproduces, its babies are more likely to have stripes as well. And so over time, you will see an increase in the percent of tigers that are striped, and that's really what evolution is all about. So natural selection is the process that weeds out the bad and keeps the good. So natural selection is really, notice that it is really an editing process. So it's a natural editor of random mutations which have already been written or which have already occurred. So natural selection is editing, it's not writing. So we speak of adaptations, evolutionary adaptations, but that's really something that we can only say with 20/20 hindsight. In this particular environment, stripes did well. So that mutation, that allele got passed on more often than not to the next generation.